All right. Apparently, we're not as cool as the rest of the people. We don't get a proper introduction, but so anyway, this is bug bounty extortion. This is kind of an outline of what we're going to be talking about. So I'm Matt Mosley. I'm the manager of threat research at Massive Labs. Our parent company is Tavora. So I have about 10 years background experience in development and security. I have a passion for pen testing, development training, all that good stuff. And this is Kevin.
Hey guys, I'm Kevin. I do whatever Matt says. Actually, I'm a consultant at Tavora as well. Been doing pen testing for a few years now and specialize in web applications and web services.
So quick overview, if for some of you that haven't read the synopsis. This was an incident that happened last summer. We had a Fortune 500 financial institution call us. They basically had a ethical hacker contact them and try to extort them for $250,000 for a bug that they had found. And so basically we're not really covering anything new, nothing groundbreaking. This is kind of a cautionary tale of what happened and how we came to the conclusion and how we solved the issues. And we're going to do a technical breakdown and then kind of the lessons learned after the incident. So again, our client receives the call, right? Again, ethical hacker. Basically told him that he found a flaw that allowed him to take over any account in their system, and with that was able to transfer money from that account to any account that he wanted to. At the time, they didn't really know how he was doing it, but they basically said we had 48 hours to find out. Otherwise, he was going to release the information on Twitter and YouTube. So it was a threat made by him. I said USD because we later found out he was from India and all that good stuff. But anyway, so Kevin actually took the call, and about an hour and a half into it, the first mission of incident response is gather the logs, right? So give me all the evidence and logs that you have. I don't know if you guys are familiar with Ron Swanson, but anyway, so they had none. It was really awesome to try and deal with a situation where you had really no path to go or no way to really figure out how they got in. So we were flying blind. So about an hour and a half into it, I was recovering from a party at DEF CON and definitely was not in the mood to think logically, let alone pen test. And so we let Kevin run with it for a little while. I don't know how many of you have been to DEF CON, but that hall, that is a journey, especially when you're drunk. You have to like pack a lunch just to go from one end to the other, right? So you know those kids at like the skating rink that don't really know how to skate, but they're like along the side of the wall? Yeah. So I'm like crawling along the wall. I get a call from my boss telling me, kind of giving me a breakdown of what's going on, and I'm just not having it, right? So Kevin and I, we get on a quick call. We start to review kind of what data we do have, right? We knew that the attacker knew the email address of one of the victim, and basically we started trying to figure out like, if we were the attacker, how were we gonna break the system? How were we gonna take over the system? So we came up with a couple attack vectors. Was an employee workstation potentially compromised? We quickly ruled that out. They actually challenged the attacker to do it again, and he did it on a brand new account, a test account. So kind of ruled out that it was anything previously installed. We did a quick vulnerability scan of the web server just to see if there was any known vulnerabilities, and then basically we kind of narrowed it down to, was there potentially some sort of flaw in the web logic, which was our initial thought. So about 12 hours into it, finally I'm back in the hotel room. I've sobered up a little bit and got to work. Kevin was already working on the web application side of it, so I knew Kevin pretty much had that locked down. So I decided to look at the mobile version of their website, and it was actually really weird. It was the same site, but different logic, different business logic on the back end. So we found honestly, it was like low-hanging fruit. Basically, in the header request, if you tried to reset the password, and you removed the security question and the answer, it would just default and let you reset the password for any account that you knew. So we're like, yeah, you get nothing, right? We're like, we did it. Drop the mic, you know, you lose. And we informed the client, and you know, I went to bed with a headache, and the next day, client's team remediated right away. Kevin quickly wrote up the instructions and got it over to them. The attacker was then able to do it again. So whatever flaw we found was not even the one he was using. So thankfully we found that flaw, and you know, that got patched. But we were just like, how the heck is this guy doing it? You know. So now we're 24 hours in, and yeah, like shit. What do we do? Start from ground zero, right? We're going back to the drawing board here. So basically, Kevin kind of decided to throw out everything we knew about it and start from scratch again, right? So I'm going to go ahead and hand it over to Kevin, talk about a little bit how he came to his conclusion. So here you go.
Sure thing. So yeah, kind of the countdown here too is we're kind of racing against the clock for this guy's can release the exploit if they don't pay the bounty. So, you know, time's tough and we're still flying blind, no idea what the flaw is, don't even know which WebLogic flaw anymore, but that's what I'm pursuing, and that's what I've been banging away at. We're exploring basically all parts of the web application that can handle password changes at this point. Because we're going blind, we don't know exactly what they're hitting. We have no really starting point, but we decided to go and look at things in the web application that can actually change the password and hopefully exploit one of those forms to make that happen. And so we narrowed it down to the forgot password workflow for resetting the password when you forgot it. The password reset in the account page, you can just go into your profile and reset the password. And the create new account page, in case in some situation you might be able to create a new account but overwrite the password of the old account. So those were the three vectors we were pursuing at this point. So the main thing that I was really trying to look at was session management. The reason is, a lot of times, there's just a lot of opportunity for mistake here when people make web applications. And the form that they had to reset passwords and the form that they had to create new accounts was very complicated. There was multiple pages, and they were all relying on state information from the session cookie. The problem with session management is it's pretty slow to test. It was a lot of a manual process for us, testing every little combination, trying to figure out how they might be doing on the back end, and you know, working out the possibilities. And we're limited on time here, so about 10 hours left, we're starting to realize that we might be able to find this, but I don't know if we'll be able to find it in time. And that's when we started noticing that there's actually, there were other calls going every once in a while back to the application that weren't a part of the application logic itself. And that was web analytics. So they were using something called IBM T-Leaf for the web analytics. And prior to this, they had not been able to get us any logs. And so we reached out to the analytics department and actually got some dumps of their analytics logs. And using this, we finally got on the right track. So getting a little more morale here, have some direction. We were able to see that they actually, there's IPs coming from India, which we knew the attacker was from India, in the time frame that we had challenged the attacker to change the password, hitting the forgot password workflow page. So this allowed us to kind of cut out some of the cruft, cut out some of the other pages, and just really focus down on this page. And still kind of going blind, but at least we had, a much more limited scope on our hands. So we refocused our effort on this page. And finally, thank God, we had about 3 hours left, and at this point, our boss was in the office just yelling at me to pull the trigger on the exploit, whatever that means. So things were getting heated, but finally did it. We were able to reset a password, and we managed to find what the flaw was. And this is, I'm going to kind of walk through the technical breakdown of what was going on here. This, like Matt alluded to, is nothing groundbreaking, perhaps, but I'm going to give a background on session management. We run into this a lot on pen tests, especially web application pen tests, where there's session management errors. So forgive me if this is something you guys have all seen before, but it might be useful, might find it on your own pen tests. So some background. I just want to give an idea of how the page worked that we were targeting. Or rather the workflow works. So in order to reset a forgotten password, you basically had to go through 3 pages, and on each page the state would change. So on the first page, you would enter your username, and that would basically just redirect you to the next page. You'd be in the context of that username, be asked one of your 3 security questions. If you answer that, so obviously, if you know the name of my dog, you should deserve my password, apparently, according to this website. But if you answer the one security question, you now have the ability to reset the password, and then that will redirect you to a change password page where you can change the password. And I wanted to do some first observations on that. Just thrown out there, the only verification needed here is security questions. Even if this form was perfectly secure and there was no flaw, there's still going to be an issue with that. The security questions they had on offer were things like what was your high school, what was your first dog, things like that, things I can know from being a friend with you on Facebook. So regardless of any technical issues, the business logic issues of how the web application worked was not sufficient to protect the page. But unfortunately, that wasn't the thing that was attacked, so there wasn't much focus on that, and that actually still hasn't been fixed. But that's something to definitely keep in mind when you're designing web pages or pen testing web pages, that even if there's not a technical flaw, you can go ahead and maybe hit something that is weak from the amount of information it's requiring you to validate. So when we were looking at the sessions, we knew it was they were using the basically pre-built Java library for handling sessions because they were using the JSession ID. And again, forgive me if this is common knowledge, I just want to cover it in case anyone hasn't gone over it before. Basically what happens is when you use this, your JSession ID is set as a cookie. That's a unique ID that identifies your session and then identifies the state, which the internal server code can reference and modify as needed. The server can add or remove or read attributes to this state, and each page could react differently based on what the attributes are. So cookies, session management. But the thing is, so for this page, right, what it was doing was adding the username attribute to the session on the forgot password. It was getting the session attribute for the security question for what user it was, and then setting, hey, this guy can go ahead and change the password if you answer the correct security questions. And on the reset password page, it's just checking what whether you have that permission to reset passwords, and if so, resetting your password. At least that's what it should be happening, right? The logic changing the state of the session cookie can really be doing anything on any page. And sometimes people make mistakes in managing state, and that's a little foreshadowing here. We basically, when we're targeting this, we want to get to the server to a state that we can use to change the password, but without jumping through the hoops of actually answering the security questions or validating ourselves. And so what we're trying to do is figure out how the backend code is working and see if we can get the state into an area where it will execute code that will change the password for us. So you probably get your reading glasses on for this, but basically what's going on here on this page, this is kind of what the session code looks like for each page. We didn't have access to the actual code, so I'm kind of mocking up what I think would look like. But essentially, right, it's checking, it's pulling out, it's creating a session or checking an existing session, adding the user to that session, redirecting to the security question pages, checking to see if the answer is correct. If it is correct, it's going to set the session attribute can change password. And then on the check session page, it's going to go ahead and check whether they can change the password, and if so, take the parameter of the new password they entered and change that password. So, it's reading the user object from the database, comparing the answers, writing the new password to the database, all the good stuff like that. And that's what should be happening. What we found to really work like, which was very strange, is that when you hit the change password page with your new password, if your session is correct, it goes ahead and changes the password. But if your session is incorrect, not only does it redirect you to the login page and says failure, it actually makes it so you have a valid session. And so I don't know why they did that, and it was really unexpected, but we kind of just bumped into that. And we were very caught by surprise and very happy that we were able to find it. And so basically, in order to exploit this, right, you can create your own account, go through a normal password change, capture the post request for the password change itself on that third page, then go ahead and start the reset password workflow with a different user, your target user. Go ahead and pull that JSession ID out now that you have associated the user with it before answering any security questions. Go back to the post request you captured, paste in the JSession ID, run it again. It will successfully, the page will fail you and go back, but then hit it that second time and boom, you're authenticated and can change the password. And so kind of just the story here is like expect the unexpected, right? Why would, if you fail to authenticate, make you authenticated? Why would the server code do that? There's no reason to, right? And that might not be something you're looking for in a web application pen test or web services pen test, because why would anyone do that? But code is weird, people make mistakes, and things can be complicated. We didn't have access to actual code. I'm sure it wasn't as simple as, if fail, then make authenticated. There's probably some more complicated logic there where there was a flaw. And so really the key is to expect the unexpected. We were going out after some of the things you might expect to be happening, but if you kind of just mess around with things that you might just logically think would fail, you might be surprised to see they'd actually be successful. Another thing is be the unexpected, right? When testing sessions and web applications in general, a lot of times all the testing that's done by the developers is against, hey, what can the user do in the browser? Is the user experience correct? But we have tools, right? We have burps where we can send arbitrary requests to the web servers. We can send it in arbitrary order, and we can inject whatever information we want in there. So take advantage of those tools and do things that the user wouldn't be able to do, or they wouldn't be able to easily do in the browser, to try and get into situations that the developer is not anticipating. So that was fun. We found the flaw, and what's kind of the moral story for the bug bounty part of it here as well. Just closing out when the time's over. So we actually suggested to the client that they should pay this guy out because he found it and he wasn't releasing it, and he deserves something, maybe not 200 grand. But unfortunately, he kind of started, I guess, calling them out on Twitter and a bunch of other networks, and wasn't professional about it. So he ended up not getting any money, unfortunately. And we actually found out later that he had purchased the exploit as soon as the client remediated it. The exploit came out on YouTube from someone else. So.
Everyone thank Doug, savior. All right, so where are we at? Lessons learned. All right. So first off, as the attacker, if you are going to find flaws and start requesting money, you probably should check to see if the company has a bug bounty program. I just rule one, I don't know. But so in this case, they did not have a bug bounty program. And so we're really trying to tell you that if you can, and if your institution has money or your organization has money, to definitely institute some sort of bug bounty program. Because basically they were left panicked and scrambling, right? They were a financial institution, and I've had this debate a few times, especially in the office, that they shouldn't do a bug bounty program because it might paint a target on their back. But I think we've already kind of illustrated they were already a target, right? Like this guy came out of nowhere, decided to spend hours upon hours trying to find this flaw, and basically found it, and then was holding him, ransom basically for $250,000, which is insane. But anyway, I think bug bounty programs are pretty easy to establish, especially for any security teams out there. There's online resources. Google has done a very good job of setting kind of a template for putting bug bounties out there. BugCrowd is another great website that you can actually sign up and put your bug bounty program on, and CrowdCurity will actually work with you to set up a bug bounty program. But some things you should probably consider when setting up a bug bounty program is valid bugs, right? What do you consider to be a legitimate flaw in your system? Some sort of cross-site request forgery that logs out a user, probably not that big of a deal, right? Because all you're doing is logging out the user. So you want to probably make that one of your invalid bugs. But your valid bugs might be something where it hijacks a session or some sort of SQL injection, right? Anything that's not going to be a big deal, I don't know, some sort of SSL error, something that we see all the time on, when we do our web app pen tests, or, I'm sure there's pen testers in the room that know what I'm talking about. Those will probably not be a big importance for a company to pay money for. And then you want to define your reward, right? So Yahoo used to send out t-shirts. That's cool. I mean, some people bitch and complain, but it really, just the recognition that you did something and got a shirt for it's kind of cool. Trophy, I know Facebook does a white hat hacker debit card. You can keep the money. I just want that cool debit card. So, but yeah, even recognition on the website, right? Like the Hall of Fame. A lot of bug bounties do that, where they actually just put your name up there. And that's really good for up and coming security researchers to try and establish themselves, especially in this market where everyone's trying to look for jobs and, security is kind of hard to get into. If you can throw your, a couple links up there and say, hey, I found these bugs and these are the CVEs that I found, you're definitely going to, have a lot of better chance of getting a job. And then another good thing is it opens a channel of communication, right? You set up rules that say you're not going to prosecute them if they disclose a bug to you. I think a lot more people would be more willing to come up and actually disclose how they did it, what they did, So I know there was a kid not too long ago in England that disclosed a bug at his school, and he's actually being persecuted now, So it's kind of scary, kind of things that are out there. But as long as you can open up that channel and set up some sort of forum for them to submit their bugs, I think it's definitely a good thing and a good step in the right direction. Another thing that you'd think a Fortune 500 company would have is an incident response team. That was probably the biggest wake-up call to us was give us your logs, and they had nothing, right? We found the web analytics logs, and we actually used them in a way that they weren't supposed to be used just because we had nothing else to use. So if you haven't already set up an incident response team or even policies in your organization, maybe that's something you should start with, right? Do you even know how to detect or analyze a breach if it did occur? Right, that was the first thing we had to do was figure out if a breach actually did occur. And so we lost valuable time doing that. So anyway, and you want to work on containing the breach and possibly recovery. And threat mitigation, right? You want to fix the problem. That's kind of what we did, right? We came in, we found the problem, we told them how to fix it, and then, post-incident, they went ahead and fixed it. So again, nothing new, but I feel like we have to reiterate this stuff all the time in the security community. So anyway, and then if you are a researcher and they don't have a bug bounty or anything like that, these are some proper ways to disclose bugs, right? This is the ethical way to do it. This is where you get your title white hat, right? You're not going out there breaking stuff without permission. So you want to inform the company or the developer privately. You don't want to disclose it publicly. You don't want to put it out on there on Reddit or 4chan or your WordPress blog or whatever. And then when you do, provide a detailed report, just like you would provide a pen test report, right? Go through the findings, detail the data that you were able to do, and kind of give them a proof of concept so that they can take it back to their QA team, to their security team, and they can rerun it through their system so it's not just a one-time fluke. And then basically give the company time to fix it. So this is where I kind of differ a little bit on Google. I think Google gives people 48 hours to fix bugs. I don't know. That's, to me, just unrealistic. I know a lot of you probably work for large enterprises. Shit does not get done in 48 hours, right? It takes weeks, months, right? So I don't know. Just give them plenty of time, work with them, try and help, offer assistance to fix it, and then, see if you can use them as a reference on your resume or whatever that you want to get that recognition. And then lastly, this is kind of what Kevin talked about a little bit, was how to do a proper password reset. There is no standard out there, but the OWASP, the Open Web Application Security Project, has done a pretty good job. Basically, you want to gather the identification. So you want them to input their username or their email on one form, submit it, verify with good security questions. This is not what's your favorite color, right? There's 64 million colors out there or whatever. But how many can you name off the top of your head? Like 10? So if I go through and I do those 10 questions, that's not a good question, right? If I do those 10 answers. So good question would be, what was the street you grew up on? I guarantee you're not posting that on Facebook or MySpace or whatever you use, Twitter. So anyway, do that. Once you've verified that the user is actually who they say they are, send a token over side channel, right? This is where the email comes in. Send them an email with the email that's registered to their account with a link that's times out after a certain number of hours, and then have them click on it to verify who they are. And then once that happens, allow them to change the user or change the password. So anyway, thank you very much. So again, Matt Mosley, Kevin Dick. That's our contact information if you want to reach out to us. Any questions? Well, I guess we did a good job. Or not. Last chance. All right, well, I'll be at the bar, so if you want to ask questions, you can. Yes?
Protocol analysis?
Yes.
While you were requesting the individual to do the thing, they didn't have any capabilities of putting up a sniffer in front of the web server or the load balancer so you could watch it?
Yeah, their team didn't. Unfortunately, we didn't have the capabilities to step in and do that. We were getting everything third party. We actually found out later on that they were actually holding information back from us. There was 4 other teams working on this at the same time, 4 other consulting firms, and they didn't tell us any of that information. I don't know why they were so hesitant to give us that information. They could have. Maybe, I honestly don't know if they did do that, but that would definitely be the route to go, right? Especially if you're trying to determine how the breach happened. So, but yeah, they didn't.
A future capability, if when you're interacting with these organizations, would you take that path?
To have that access? Oh yeah, definitely. Yeah, if they're willing to give you that access, I definitely take it. Right? You wanna see what any entry point that they're giving you. So we were flying blind. So luckily and the reason we found it is because the other 3 teams weren't focusing on the web application. I forget why we actually focused on the web app. It was something to do. I think it was something to do with the transferring the money. And we figured there was only really a couple ways they could do it, right? Through the mobile app, the web app, or a brick and mortar store. And so we kind of determined that it might be the application, right? 2 of the 3. So that's how we kind of came to that. But yeah, the 3 other teams, I don't even think were chasing that rabbit, were they? So
yeah,
I think their internal team might have. But yeah, and the IBM T-Leaf logs that he referenced, that was actually really cool. I'd never even seen that technology. Has anybody worked with that technology at all? It's called IBM T-Leaf. It actually records all of the sessions on the website so that you can watch mouse movements and everything for users, so you realize like what they're clicking on and stuff. And that was when we asked them for logs and we started seeing the T-Leaf requests in the headers. We asked them what that was, and once they gave that over to us, we could actually replay what the guy was doing. We couldn't see the header requests, where he was switching the session IDs, but we could actually see what he was clicking on and doing. That's how we kind of narrowed it down to the password reset. So it was very interesting, actually. So, any other questions? Good? All right. So again, not really covering anything new, but cautionary tale. Hopefully you can take this back to your organization and, maybe you'll find a password reset flaw in your stuff or some sort of business logic. So anyway, take care. Thank you very much.